You won't believe the size of the largest black hole. It's a number so vast, so utterly disconnected from our everyday experience, that our minds struggle to even find a starting point. Forget mountains, forget planets, forget even our own sun. We are about to journey to the edge of cosmic comprehension, to meet a monster that defies imagination. I'm sure you've heard the news. Stories of black holes pop up all the time, each one seemingly more massive than the last. But this is not a typo. It's truly gargantuan, bigger than anything you can picture. Before we meet this cosmic titan, let's get grounded. What exactly a black hole? Forget the sci-fi tropes of cosmic vacuum cleaners. The reality is far more elegant and far more terrifying. A black hole is what's left behind when a truly massive star dies. After exhausting its nuclear fuel, the star's core collapses under its own immense gravity. It squeezes an incredible amount of matter into an infinitesimally small point, a singularity. Imagine crushing a mountain down to the size of a grain of sand, and then keep crushing it. This creates a region of space-time with a gravitational pull so strong that nothing, not even light, can escape. The boundary of this region is called the event horizon. It's not a physical surface you could touch, it's the point of no return. Cross it, and you are forever cut off from the rest of the universe. The spectacular light show we often associate with black holes, that's the accretion disk. It's a swirling vortex of gas, dust, and shredded stars that have strayed too close. As this material spirals inward, friction heats it to millions of degrees, causing it to glow brighter than entire galaxies. The black hole itself is invisible. What we see is the final brilliant scream of matter before it disappears forever. Now, not all black holes are created equal. There are stellar mass black holes, just a few times the mass of our Sun. Then, there are the supermassive black holes, lurking at the centers of most galaxies, including our own Milky Way. These are millions, or even billions, of times the mass of the Sun. And then, there are the ultramassive ones, the record breakers. For a long time, the undisputed champion was a behemoth called Ton 618. This isn't just a black hole, it's a quasar, an intensely luminous object powered by a black hole feeding at a furious rate. Ton 618 weighs in at a staggering 66 billion times the mass of our Sun. It's a cosmic monster, so bright it outshines its entire host galaxy. But recently, astronomers found something that makes even Ton 618 look modest. Meet the current heavyweight champion of the known universe, the black hole at the heart of the Phoenix cluster, a colossal gathering of galaxies 5.7 billion light-years away. This black hole, let's call it Phoenix A, is estimated to be 100 billion times the mass of the Sun. Let's pause on that number. 100 billion. That's not its size, it's crucial to distinguish between the two. The physical size of a black hole is defined by its event horizon, the Schwarzschild radius. While Phoenix A is incredibly massive, its event horizon is only about 100 times the distance from the Sun to Pluto. Vast, yes, but its influence extends far beyond that. Its mass dictates its gravitational dominance over its entire galactic cluster. So how on earth do we weigh something we can't even see, billions of light-years away? It's a brilliant piece of cosmic detective work. One of the primary methods is by observing the orbits of stars and gas clouds near the galactic center. Just as we can calculate the Sun's mass by observing how fast the Earth orbits it, astronomers can measure the speed of stars whipping around a galactic core. The faster they move, the more massive the central object must be. For more distant quasars, they use a clever technique called reverberation mapping. They watch for flickers in the accretion disk's light. This light travels outwards and illuminates gas clouds further away, causing them to glow in response. There's a time delay between the initial flicker and the cloud's response. By measuring this delay and the speed of the gas, scientists can calculate the distance of the clouds from the black hole, and from there its immense mass. It's like shouting in a canyon and timing the echo to figure out how big the canyon is. And then there's nature's own magnifying glass, gravitational lensing. As Einstein predicted, massive objects warp the fabric of space-time. Light from a distant galaxy passing near a massive black hole will be bent and magnified. By analyzing the distortion, astronomers can map the distribution of mass and calculate the weight of the lensing object, the black hole itself. Space bends. Your mind stretches. Now, let's try to visualize the scale of Phoenix A would have the mass of a giant mountain. Its event horizon would stretch far beyond the orbit of Pluto. Our entire solar system would be like a tiny speck of dust caught in its gravitational well. If you were to replace our sun with it, an impossible scenario, but a useful thought experiment, it wouldn't just swallow the Earth. Its event horizon would engulf the entire solar system and extend thousands of times further. The gravitational pull would be so immense that the outer planets would be ripped from their orbits and the inner planets consumed in an instant. And that's not even the weirdest part. Near such a massive object, time itself behaves differently. This is time dilation. For an observer far away, someone falling towards the black hole would appear to slow down, their image frozen and red-shifted at the event horizon for eternity. But for the person falling in, time would pass normally as they cross the horizon, while the entire future of the universe would flash before their eyes in an instant. This brings us to some common myths. Black holes are not cosmic vacuum cleaners, roaming the universe and sucking up everything in their path. They are governed by gravity, just like stars and planets. If you replaced our sun with a black hole of the exact same mass, Earth and the other planets would continue to orbit it just as they do now. It would just get very, very cold and dark. You have to get very close, inside a region a few times the size of the event horizon, to be in real danger of being pulled in. So how does a black hole grow to be 100 billion times the mass of the sun? It's a story of cosmic cannibalism and relentless feeding that spans billions of years. The primary way is through mergers. When galaxies collide, their central supermassive black holes eventually find each other, spiraling inward in a gravitational dance that culminates in a cataclysmic merger, forming an even larger black hole. The other method is accretion, the process we see in quasars. During periods of intense activity, especially in the early universe when gas was plentiful, these black holes fed voraciously. They consumed vast clouds of gas and dust, growing at an incredible rate. Phoenix A is currently in a relatively quiet phase, but it's estimated that it was once growing at a rate of 60 suns per year. The existence of such massive black holes so early in the universe is actually a major puzzle for astronomers. How did they get so big, so fast? It suggests that the seeds of these black holes might have been much larger than we thought, perhaps forming from the direct collapse of gigantic primordial gas clouds, rather than from single stars. The quest to understand these giants is pushing the boundaries of technology. The Event Horizon Telescope, a planet-wide network of radio dishes, gave us our first ever image of a black hole's shadow. The James Webb Space Telescope is peering back to the dawn of time, hunting for the first galaxies and the seeds of these supermassive black holes. And upcoming missions like LISA, the Laser Interferometer Space Antenna, will detect the gravitational waves from merging supermassive black holes, allowing us to hear the universe's most violent events. Every time we look deeper, the scale of the universe gets rewritten. Objects like Phoenix A are not just curiosities. They are fundamental architects of the cosmos. Their immense gravity shapes the galaxies they inhabit, regulating star formation and sculpting the large-scale structure of the universe. They are the silent, massive hearts around which everything else revolves. So, are you mind-blown yet? From a point of infinite density to a monster weighing 100 billion suns, the story of black holes is the story of gravity at its most extreme. It's a reminder that out there, in the silent darkness between the stars, there are forces and scales that utterly dwarf our human perspective. Space just got a reality check. And the best part? We're only just beginning to understand it.